Greetings of the day, dear students. In this video, we are going to discuss about the significance of back EMF, right? If you observe the principle of operation of the motor, right? Motor is a DC motor is a device which converts the electrical energy into mechanical energy, right? And you are going to have armature winding and field winding, right? For field winding, you used to give the DC supply, right? Now, when this motor, it makes the significance of the back EMF is it makes the motor to draw as much current as is just sufficient to develop the torque required by the load. Torque required by the load. What happens is when the armature rotates, right, the conductors present in the armature also are going to rotate, and those are going to cut the flux produced by the field winding. Now, according to the Faraday's law of electromagnetic induction, what happens is some EMF will be induced in the winding and whose direction is given by the Fleming's rule. And one more thing is that this induced EMF is going to oppose the applied voltage. Whatever voltage you have applied across the terminal, that voltage is being opposed by this induced EMF. Now, because of its opposite direction, this induced EMF is referred to as back EMF. Back EMF. If we have observed with respect to the generators, right, you have seen the generated voltage is given by EG equals to 5Z NP by 60A. 5Z NP by 60A. Similarly, here also with respect to the DC motor, the back EMF developed is given by EB equals to 5ZNP by 60A, where 5 indicates the flux, Z indicates the number of conductors, N the speed in RPM, P the number of poles, A the number of parallel paths. Now, depending upon the type of the winding, whether it is wave winding or lap winding, okay, if it is lap winding, A will be equal to the number of poles. If it is wave winding, A will be equal to the 2, right? So by substituting all those values in this formula, EB equals to 5Z NP by 60A, we can calculate the back EMF developed in the motor, in the DC motor. Now, one more point we can observe. For example, if the speed is high, of course, at the starting stage, observe the motor will not be at high speeds. The speed will be low. So, the back EMF also will be less, and it is going to draw more amount of current, and in order to develop the sufficient torque, in order to develop the more amount of torque, what happens is it is going to draw more amount of current. Slowly with the increase in the speed, what happens is now this back EMF becomes large enough so that the current drawn by the armature will be small. The current drawn by the armature will be small, right? So this back EMF is also depends upon the speed. If the speed is high, the EB will be large, so obviously IA amount will be small. Otherwise, if the speed is less, what happens is the back EMF will be less, and it demands more amount of armature current to develop the sufficient amount of torque. Clear? So in this entire discussion, EB equals to 5Z NP by 60A is important. Okay, thank you.